friends, today we are going to discuss the most important topic in the chemistry is carbonates. These are the elements which plays a very important role in the chemistry of in the inorganic chemistry, and here we will discuss the silent feature of borane and carbonate and their molecules form with different elements. I will start from the borane and I will go to the carbonate. First we need to understand that what is borane, and then we will study the carbonate. First, all the hydrides of boron are called as borane, and all the mixed hydrides of boron and carbon are known as carbonate. That means all those molecules which are made up of only boron and hydrogen comes under the category of borane, and the same if a molecule is having boron carbon along with the hydrogen atoms, then this category will be termed as carbonate. There are many other boranes are also reported in the chemistry, just like hydride of gallium known as gallium, and hydride of silicon known as silane. These are the basic molecules which generally occurs in the nature or can also be synthesized by different chemical and physical methods. So here first we will discuss that why is boron is important. Basically when you will see the chemistry of boron, you will understand that boron has a high melting point. It is generally found in isohedral state, and the molecular formula is B12. So dear friends, now we will see the structure of this molecule. So the general structure of this molecule is like this. This will be the isohedral geometry, and the point group of this molecule will be IH. The total number of faces in this molecule is 20. Total number of vertices is 12, and it is well known for its higher symmetry. This is the higher symmetry molecule. So here you can see that this molecule belongs to the icosahedral or isohedral point group, which is represented by IH. Total number of faces in this molecule will be 20. Total number of vertices in this molecule will be 12, and molecule is also very stable because of its higher symmetry molecule, and higher symmetry in this molecule makes it more stable as compared to other elements. The solid state geometry of this molecule is rhombohedral geometry. So this molecule have a rhombohedral geometry which gives its more stable structure, and this structure is also very stable in solid state. Now we will have a simple structure of this molecule like BH3. Suppose we have a molecule, general formula is BH3, which is a fundamental borane. It is a fundamental borohydride. If you see its structure, then its structure is like this. Its structure is fan-like structure. Its point group is D3H. It is also a electron deficient species, so we can term as it electrophile, or can also name this molecule as Lewis acid. So if we have a simple structure like BH3, so these are the basic properties which it has. Basically, its structure is fan-like structure. Its point group is D3H. Its nature as an electron deficient molecule, and so it will act as an electrophile. And all these type of molecule will comes under the category of Lewis acid because of its electron deficient nature. So if it is a Lewis acid, then what will happen if it gets a molecule like electron rich? So like it is react with lithium hydride, so it will give a lithium salt of borohydride, or if it is react with NS3, a very well known reaction, then it will form a adduct BH3 NH3, this lone pair of electron will be shifted to the BH3 molecule. Suppose we are reacting this molecule BH3 with the carbonyl molecule, then a borohydride carbonyl complex will form, and it is just because of the electron rich nature of these molecules. This is also electron rich molecule, this is also electron rich molecule. So these electron rich molecule immediate will form an adduct with the BH3 molecule, because this is Lewis acid, and these two will act as a Lewis base. The another property of this borane are when this borane exposed to air, it will form borane anhydride. So in a simple reaction, suppose we have a molecule which general formula is B2H6, which is generally known as diborane, and when it reacts with the NH3 molecule, which is also act as a Lewis base because it is an electron rich molecule, then boron nitride is formed, and its general formula is also known as inorganic benzene. And if you see the structure of this molecule, then it will be like this. It will be formed like this, and here will be charge of plus, and its general name is boron nitride. Boron nitride. These are the fundamentals of the borane and borane molecule. Now we will go for the classification of this molecule. Classification of borane. So the following category generally exist in the case of borane. The first is the closoborane, second is the nidoborane, third is the arachnoborane, and fourth is the hypoborane, and fifth is the conjunctoborane. So we can classify the borane in the following category. The first is the closoborane, second is the nidoborane, third is the arachnoborane, fourth is the hypoborane, and fifth is the conjunctoborane. So we will discuss it one by one. If you will see the closoborane, so its structure is closed type, yani ki, its geometry is closed type, and if you will discuss the nidoborane, so its geometry or general structure will be nest-like, and if you will discuss the arachnoborane, so its structure will be spider web-like, and if you will consider the structure of hypoborane, so it will be the anionic form. If you will discuss the borane of conjuncto, so its structure will depend on any of the two these borane, means its structure it depend on the above any of the two borane mixture of two borane, any of the two borane structure mixture. So if you will consider the general formula of this molecule, so it will be BN HN 2 minus, where N is equal to 6 to 12. If you will consider the general formula for next light structure, so it will be BN HN plus 4 or BN HN plus 3 minus. If you will consider the structure of spider like arachnoborane, it will be like BN HN plus 6. And if you will see the structure of hypoborane, it will be BN HN plus 8. These are the general formula. If you have a closoborane, so its general formula will be BN HN. Whole will get minus 2 charge. If you have a nidoborane, so its general formula will be BN HN plus 4 or BN HN plus 3, total minus charge. Arachnoborane will be the general formula of arachnoborane will be BN HN plus 6. Hypoborane have the general molecular formula is BN HN plus 8. So these are the general formula for the formation of carborane. So now we will discuss one by one by taking the example of some boranes. Now we will go for the structure of few borane. Like suppose you have a molecule like B2H6, Now its structure will be like this. Molecular structure will be like this. If you see the general electronic configuration of boron will be 5b, 2s, 2p, 1, 2, 3, boron in excited state, it will be 1 and 2, 3. So the general hybridization for boron will be sp2. So the general formula will be sp2. So these boron having the general hybridization. These two boron have the general hybridization is sp2. Now from here you can see in this structure there is a possibility. Number of possible bond is one is BH bond, second is BH2 bond. First is the BH bond. Second possibility is the BH2 bond. And third possibility is the BHB bond. So there are two type of bonding are generally possible in this type of borane. So now we can summarize these borane in a simple formula which is generally known as Stokes code. Now I will discuss the Stokes code in detail. Suppose we have a general formula of Stokes code is like STYX. Suppose we have a general formula is STYX. Here this code is working only for the borane molecule. Suppose this STYX represent the specific bonds. Suppose S is representing the number of BHB bonds, number of T is representing the number of B bonds, Y is representing the number of BB bonds, and X is representing the number of BH2 bonds. So suppose we have a number of these bonds, so we can generate the general formula of any of the borane, or if we have the borane molecular formula, we can generate the STYX code for each of the borane molecule. Now again I will go to the structure of B2S6, which was like this. When you will record the proton NMR of this molecule, you will get two signal. That means there are two type of protons available. One is the bridging hydrogen, and second is the terminal hydrogen. These two hydrides gives the two signal for this molecule, two HNMR signal. This is also a very important question which is generally you can get in the competitive examination. Suppose in the next time when you are doing any of the study, you are asking anyone is asking about the number of H1 NMR signal present in the B2S6 molecule. So the answer will be 2 NMR, because there is two type of hydride molecule are present. These are the in the same environment, but if we talk about these two molecules, so these two hydrogen atoms have a different chemical environment, so these two hydrogen will give another signal. So in B2S6 molecule there will be two signal. Now again we will come to our previous topic, which was STYX code, where STYX represent the different type of bonds present in the B2S6 molecule. Now we will proceed from here. If you see in the BHB bond, we can also name these bond as a 3-center 2-electron bond. These BHB bond can also be represented as 3-center 2-electron bond. If you are writing a BBB bond, so this type of bond also considered as a 3-center 2-electron. And if you are asking about the BB bond, so it will be 2-center 2-electron bond, where in BH2 molecule it will be 3-center 2-electron bond. So now here you can easily understand these HTYX code generate the different type of bond present in the borane molecule, which is also named as the C center 2 electron bond, 3 center 2 electron bond, or 2 center 2 electron bond, and 3 center 2 electron bond, depending on the nature of the bond. Now we will proceed. Suppose we have a molecular formula, the general molecular formula of a borane, which is B4H10, and we have to draw its structure. So first we have to generate its STYX code. So if we want to calculate this STYX code, so we have to draw its structure. So suppose this molecule can be drawn like this. This molecule like this. There will be one permanent bond, bridging bond, bridging hydrogen, bridging hydrogen, bridging hydrogen. This will have a 2 hydride. This will also have a 2 hydride. This will have a single hydride. So now we can count the number of boron: 1, 2, 3, 4. Total 4 boron, that is 4 B4, and 10 hydride, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 hydride is also available. So its STYX code will be S is represented for the BHB bond, which is VHB1, VHB2, VHB3, VHB4. So it's S for 4, T4. If you will consider the T, then T is the BBB bond, B bonds. This BBB bond will be 0. And now Y is represented for the BB bond, and this BB bond will be 1. And X represent the BH2 bond, and this BH2 bond is 2. VHH, that is 2. The total STYX code will be STYX code will be 4, 0, 1, 2. So for V4H10, the STYX code will be 4012. Now there are many other molecules when draw for the STYX code. A few of the general formula is suppose we have B6H10, V6H10, V5H11, V5H9. These are the molecule where we can generate the STYX code for these molecule. Now I will just write down the STYX code of these molecules. Suppose I will draw a series. Suppose we have B4H10. The STYX code will be 4012. Suppose we have B5H11. Its STYX code will be 3203. Suppose we have B5H9, its STYX code will be 4120. B6H10, its STYX code will be 4220. These are the molecule where the following will be STYX code of this molecule. So these STYX code can determine their structure. Structure can also determine by using STYX code. I will discuss the carborane molecule in my next lecture. Thank you.